Thank you for joining this lesson. We're going to look at circle chords and tangents together with angle properties in a circle. In the figure below, O is the center of the circle. Then a PQR is a tangent to the circle at Q. Angle PQS equals to 28 as indicated on the diagram. And angle UTQ is 54 as indicated. Then we're also given that length UT is equivalent to TQ. So this length and this one are equal. From there, we proceed to the questions. Giving reasons, determine the size of angle STQ. STQ. STQ is the angle at this point. It's good to know that the value of this angle, we are just going to conclude it right away from this concept. If a chord is making an angle with a tangent, we have a tangent here, and chord SQ is making an angle with it of 28. And the same chord happens to subtend an angle to the circumference on the alternate segment, then the angle subtended there is also equal. So that angle is 28. So the angle will be 28 degrees. It is the angle in the alternate segment. Angle in the alternate segment. It ought to be equal to the angle made by the same chord and the tangent. Those angles are usually equal. We proceed to the next. TQU, TQU, TQU. That will be the angle at this point. Let me draw the line to make the angle complete. TQU is going to be the whole of this. Sorry. Yeah, the whole of this angle. The whole of this. The whole of that. We can talk of, because this is 54, then the base angles here, which are 2, are going to be equal. Therefore, we take 180 and we subtract 54. We get 126, then we divide by 2. This gives us 63. So the angle there is 63. 63 degrees. These are base angles of isosceles. Isosceles triangle. Base angles in isosceles triangle should be equal. That's why we have taken the remainder in that triangle and we've divided it by 2. So this is a 63, the whole of it. We can also talk about other angles like TQS. TQS. So TQS is the angle at this point. The angle at this point. Remember, the whole of this is 63. The whole of that angle is 63. And following TSQU, that is a cyclic quadrilateral. Then the angle at T, which is a total of 82, because we have 54 and 28, is an opposite angle to the angle at Q. Therefore, we can say, because opposite angles in a cyclic quadrilateral add up to 180, then for us to get the angle at Q, we need to take 180 and we subtract the angle at T, which is the angle at T, which is 82, which is 82. So 180 minus 82, giving us 98. Then now, because the whole of this now, which the opposite angle is the whole of this, so 98 is the whole angle, SQU, 98. Now to get TQS now, the angle in question, we should take the whole angle of 98 and we subtract 63. So 98 minus 63 gives us exactly 35 degrees. 35 degrees. So we'll talk about 35 degrees. The concept we have used here is opposite angles. opposite angles in a cyclic quadrilateral. Cyclic quadrilateral. Those are angles which are supplementary. In simpler terms, they add up to 180. We are also told to find in part D the reflex angle UOQ. UOQ. UOQ, the angle at this point. That is the angle we are needed to calculate. We should know that with a chord UQ, which is subtending an angle at the circumference of 54 degrees, then the same chord should subtend an angle at the center, which is a double the angle at the circumference. So we take 54 by 2. This gives us 108. But now this is not the angle we want. We want now QOU or UOQ, but now the reflex one, which is greater than 180. So we take 360, we subtract 108, and this gives 252 degrees. So the value of this angle is 252. I'm going to put it down now. 252. The mathematical concept we have followed is angles at a point. Angles at a point. The angles at a point must add up to 360. And finally, angle TQR. Angle TQR. TQR is the whole of this angle. TQR, the whole of this angle. TQR, the whole of this. TQR. It's good to know that angles on a straight line add up to 180, and we are already having 28, and we are already having 35 at this point. So we can get the whole of the remaining angle now. We can get the whole of the remaining angle. But we can use even several other methods, because if UQ is a length subtending 54, then it is supposed to leave an angle of 54 at this point with the tangent. So with 54, and this is there is a 63 at this point, then it is easier to get. We can talk about 63 plus 54. Let me check what I'm getting. It is 117 degrees. Or let's talk about angles at a point. With 180, we subtract 28 and 35. 28 and 35. So I'll take 180 minus 28 plus 35. This is equal to 117. So any of those approaches will give us 117. So the angle is equivalent to 117. And we can use any of the properties we have applied, like angles at a point, angles on a straight line, angles on a straight line. Thank you so much for following. Subscribe and share.